Hi there, welcome to the Productive AI Podcast. I'm your host, Troy Angrignon, and today I have Daniel Jeffries on with me, and I've really been looking forward to having him on the podcast. I think we're going to have a really interesting discussion around the AI space and the machine learning space and kind of what's happening in the industry at a very, very high level. And so, Dan, thanks very much for coming on.
Thanks for having me on. I really appreciate it.
So, what I want to do first is do a little bit of an introduction. I think you're very much a Renaissance man. I think you're just an interesting guy. You're into a lot of things. So, I'd love to start with just a brief introduction from you about how you describe yourself before we sort of get into a few quick warm up questions, and then we'll get into the bulk of the conversation.
So I think in my official bio, I describe it as like author, engineer, podcaster, public speaker, whatever. I mean, there's a million different things in there, and that's because I've just studied a lot of different things and I go where my interests are, right? And I think too many people they kind of just silo in on an individual thing. We used to have this kind of education where we studied a lot, right? And we you had to learn the classics and you had to learn about music, and now we've kind of gone away from these types of things. Whereas I think when you study tons of different things, you find a ton of overlap, and it gives you this kind of incredibly broad-based perspective. So I've always gone wherever my interest leads me. I was an engineer for 25 years. I've been an author for 20 years, and whatever has kind of got me fired up is where I go next. And that's a I think Naval says that's sort of a key to life, right? If you try to fake it and go where people tell you to go, you're never going to be interested enough to really go all the way.
Mm-hmm. Yeah, and it's great. I love the fact that you sort of write on all different things. You write on crypto, you write on finance, and around AI and machine learning and engineering and systems and politics and culture. And it's I love the sort of the breadth of the content that you're putting out in terms of your places that you're writing. We'll put a bunch of the links of your sort of materials at the end in the show notes. So let's do a quick set of questions. You think billionaires going to space are a good thing? Why? Let's do a rapid fire Q&A before we dive into the conversation.
Look, because the space race is moving out of a very inefficient like government push and spending, right? Whereas like actually none of the projects were there to get super efficient when the government is the only contractor. In fact, most of them are figuring out how to say like let's make them spend 10 times as much. So that's how you end up with no rocket that's reusable. And then you get someone like Elon Musk to come around and he goes, wait a minute, if I drive my car to the grocery store and it goes into the drink every time and I have to go get a new car, that's not a very good design. So he's trying to drive the cost down, right? And when you drive the cost down, you can put up more rockets, put more things into space, and really, people focused on too many small things, right? They're just it's rich people going in space joyriding. But the thing is, you've got more efficient fuel coming out of Blue Horizon, and you've had thousands of different spin-off technologies, everything from heart surgery to the chemo chip in your phone that makes pictures possible to um, cochlear implants. All of that's come from the space race because it's the hardest, harshest, most incredibly demanding environment in the world, and the technologies that come out of it are incredible. So the fact that we're moving into this arena where it's going to be a private enterprise competing against each other is just going to drive the cost down and let us do amazing new things. And people are focused. They're too short-sighted nowadays, and it's kind of ridiculous. Actually, I think we've jumped the shark in terms of big tech criticism. You want to look at companies like doing crazy stuff. Go look at Union Fruit, inciting a revolution in Guatemala and keeping slavery running for 40 years. Or look at the British East Indies Company, which took over India with an army, personal army, twice the size of the entire British army, and it, held it for 100 years. So if you think companies have too much power now, you haven't read too much history.
All right, shifting gears. Next question. You're a science fiction author. You've been writing for, as you said, you've been an author for 20 years. You write science fiction. You made a couple comments on some of your posts about some, I would say, seminal works in the science fiction space. Gattaca, you said, was a very underrated movie. I would highly agree with you on that one. You made an excellent reference to Isaac Asimov's Foundation series. Funny side note, my first software company I started was when I was 12, and it was called Foundation Software, based on that
Awesome.
book, based on
Awesome.
that series, actually. I totally fell in love with the series. So have you seen the series that just came out on Apple Plus or
Yep.
whatever? Yeah, what do you think?
We've been loving it. I think it's funny when you look at the reviews. People either think it's total garbage, or they're just in love with it. As a writer, I understand the modifications that they made. Right? I mean, they took the genetic dynasty where you've got the young, middle-aged, and old version of the emperor, because you want to have the same actors kind of coming back for a period of time. Otherwise, you're just kind of jumping around constantly. And I think some of the best content has come out of their original ideas. And even if it's not a perfect facsimile, you can't. I mean, if you go back and read Foundation now, let's be honest, like it's a lot of old men smoking cigars and talking about stuff that happens off screen, right? So it's beneficial to move it on screen, and even if you update it, there's also not too many women in it. So they went and they added a few female characters who aren't secretaries. So I think they did a great job in terms of modernizing the content. It's not a one-to-one facsimile, but I've really enjoyed the visuals. I've enjoyed kind of the updates that they've done, and the original series is still amazing in its own right too.
Awesome. All right. Next category. We're going to get to categories in a sec. Next category would be predictions. You're big on sort of prediction, and not predicting in the sense of things were either or, but more, hey, here's a probability field. Here's a probability distribution of, based on what we see today, these are things that are more likely to happen or less likely to happen. Give me some of your best predictions and a couple of your worst complete failures at predicting.
Well, we've talked about these in a couple of the articles. I think you pointed them out that, I saw artificial intelligence ASICs, or essentially artificial intelligence chips, about a decade before they started, coming to production. In fact, I pitched it, one of the concepts, to my friend Chris Dixon before he was a famous investor in Andreessen Horowitz, and then checking out on the idea because I thought I was just too young. But I thought you could really, put these as I visually envision them as an artificial intelligence card next to the graphics cards in video games to start with. And who knows, if I had the courage to do it, maybe the industry would be farther along already. But they've inevitably kind of came, they came to pass from like kind of the amazing graphics cards that we had. AlexNet, obviously taking advantage of them.
Right.
So things like that was probably, some of my earlier predictions. I had a recruiter when I told him I wanted to go and, work in Linux, and he told me, look, all the jobs are in Solaris. And I said, look, Solaris isn't going to be here in a decade. And he looked at me like I had two heads, right? So,
I remember those days. I was around when that was ending and Linux was taking off.
Yeah. And going to work at Red Hat, right? I mean, when it was just a small amount of people and people didn't understand why I would do that, or even going to work in the early internet. And when I had to explain to my friends and my family why anyone would want to do it, it's just an information retrieval system. It's just for stupid stuff. Like, why? And I'm like, no, it's going to change everything. I was like, like David Bowie or whatever. If you've ever seen that old thing, it's like, it's an alien life form. It's, I was it's like that. Probably the worst one though, I think I've called attention to was my dad said that we don't have to worry too much about the rise of the surveillance state because there's not all these cameras that are getting deployed, CCTVs. I said because there's not enough people to watch them, and it wouldn't scale. And of course now we have artificial intelligence can scale just fine and do mass level kind of object detection. So I was pretty off in that one. And there's been a few others. I thought actually I'm working on a futurist book right now for a series of predictions across like the next sort of 25 to 50 years, looking at everything from biotech to AI to evolution of money. Awesome. And one of them I think I may be changing my mind on is, I kind of was of the mindset that robotics would be one of the first things that kind of displaced workers or changed the field in artificial intelligence. And I had this revelation the other day when I was watching a street sweeper in Berlin, and I said, "Boy, that person's doing a very complex thing. Like they're moving their hand to clean off the bristles, deftly moving out of people's way, sweeping it. This is a complex dance, and it turns out in artificial intelligence, the simplest things, the things we take for granted, moving our fingers and chewing and dancing and mass perception, these are hard. And so I actually think the low-level cognitive things are going to kind of go first, and some of these sort of like where we have to interact with the real messy world with physical objects is actually that the gardeners and the street sweepers and stuff have a heck of a lot longer than I originally imagined. So you can't always get them all right, but the thing is, people want to be right 100% of the time, and actually even in politics, we tell people don't, oh my God, he changed his mind. God, I hope he changed his mind. Like I hope that somebody got some new information and learned something, and they decided to like update their understanding of things. But we seem to value in life freezing your understanding of things and holding it at all costs, no matter what new information comes in. I think that's the height of stupidity. And you have to constantly be taking in new information and updating your probability. It's basic Bayesian logic. You get new information, right? And like it turns into a better prediction by integrating the new information, not freezing yourself in place.
Yeah, being adaptable and being willing to re-examine your own beliefs and take in that new data and then say, oh, I now have a new position because I had new data.
That's right.
Yeah. Okay. Still on the track of predictions, you know that Kai-Fu Lee just co-wrote a new book, AI 20, what is it, 2041?
2041. Yep.
2041. Have you read it yet?
I'm about halfway through it, actually, as we speak.
Okay. What's your take? What do you agree or disagree with very quickly on anything you've come across so far?
I was happy to be reading because I'm working on a futurist book. So I'm reading old futurist books, new ones, and history books, right? And trying to see like what stance do they take. I thought they took a cool stance of having somebody who's a futurist and somebody who's a short story writer basically talk about a particular subject and then use a short story to illustrate it. I thought they pushed forward a lot of the positive aspects of artificial intelligence as well, which is usually rated. I think most of the artificial intelligence stories out there have generally been like, it's Terminators, it'll kill everyone.
Dystopian.
It's super consciousness taking over the world.
Sure.
It's always the same kind of crap over and over again. And I admire them for really having a strong engineering mindset, pushing forward. I thought the stories were a little uneven, and some of them were a little on the nose, and some of them were really cool. I thought they took place in, the one that took place in Lagos was incredible. The sort of evolution of deepfakes and how it could affect politics and the types of systems we'd have to have in place to detect it. Sort of antiviral, the same kind of an evolution of antiviral systems for AI, looking for minute distortions in the video and vein detection and a million other things to try to stop kind of what's going to make video very unreliable in the future. So I just thought it was cool that team was trying to do a different take on this and wasn't doing the same old stories that we've been telling since the 1960s. And I love 2001: A Space Odyssey, but we've had a lot of water under the bridge. It's time to update, and get a deeper perspective on things.
That's great. And I'm looking forward to it. I actually hadn't dug into it yet, so I'm glad you've got a head start on that one for me. So one last prediction, and it's actually going to kind of lead into the rest of the conversation. You made a comment in one of your articles, I can't remember which one, I think it was the general prediction article that I was reading, that you put it about a 65% probability that we're really kind of that the coronavirus and this whole COVID thing has been really the beginning of something that's going to reshape kind of our world basically for decades. This isn't a moment in time. This isn't a 2-year exercise. This is a multi-decade sort of event in our history, and that it's kind of catalyzing genetics and the remaking of work, the work from home kind of thing, the rapid ascent of AI, and sort of this tension between privacy, centralized control, distribution of control, things like that. Just talk about that for a couple of minutes and share your thoughts on that.
Look, if you look back historically, there are three like major traumatic events in society that tend to shape things, right? Plagues, economic collapse, and war. Right. And they tend to put a lot of pressure on a societal level system, right? What I tend to call societal level algorithms. Right. And when you put a lot of pressure on things, look at all the technologies that, for instance, kind of came out of World War II. Like my grandfather talks about, sitting on the fuel tanks and usually the planes would come side to side and rake it and they would have that buzz. And he saw for the first time these jets coming down. And they didn't know what it was, right? And so you have this sort of jet engine technology, right, come out of there. You had, nuclear technology come out of it. You had just all kinds of like, advanced battlefield medicine, right, and antibiotics, all the things that kind of came out of the flu. So these things put tremendous pressure on the system, and they alter it in very specific ways. Again, it's a societal level algorithm. It pushes it to accelerate in areas that were dormant. So you look at something like the mRNA vaccines. People think that they're brand new and experimental. They've been around for like 10 to 15 years, right? And they've been pushing forward with slower and slower progress. It's not just one breakthrough, it's lots of little breakthroughs that are sitting there. But all of a sudden you have this tremendous pressure that kind of creates the diamond. And all of a sudden, all the different ideas come together very quickly, and you have this tremendous progress. Using mRNA itself is a revolution, right? You no longer have to necessarily craft an individual chemical compound for every single disease. You literally have the code of life and it's a very short acting thing, and you just send it in there. The cell makes the thing that you want it to make, and then it's done. It runs through the tape and it's finished. So you literally can attack almost any major disease. And what I think is amazing about it is there are many diseases that are just never going to be attacked with traditional medicine, right? In the current phase, right? You have 6,000 different genetics diseases that are too small because not enough people have them. And like any business, it's a for-profit business, and people don't like to think about it.
No, it's absolutely a power law curve if you look at it.
Of course, you've got a 10% success rate and it's $1 billion to put in a drug. Of course, you're going to focus on AIDS, you're going to focus on cancers, whatever, but you're not going to focus on the disease that I think the Moderna CEO was talking about, where the poor kids who, there's 1,000 or a couple thousand people in the world who can't produce a certain, one genetic tweak, and they can't produce, melatonin or something crazy. And the only solution is to be under a heat lamp for 12 hours a day, and you die at 18 anyway. Right? So these kind of horrific diseases, we should be able to attack these kinds of things with personalized medicine and being able to kind of rapidly sort of print up these things. The other thing is, when you look at how fast they're able to create the vaccines now, people think this is some kind of crazy magic, or think it's more experimental. No, nowadays you have this open genetics. You could say, good, we're going to copy the spike protein. That's the most unique thing. And we're going to go ahead and tell the cell to synthesize that, which teaches the body how to attack it. It's actually more natural, because now your immune system is doing work. You're just training the immune system, and they can basically come up with the solution for a lot of these diseases in 4 or 5 days, right? 10 days. The long period is still the testing process, right? That's the year plus of putting it into trials and doing all the kind of messy work of putting it into the real world. But I think you now have the largest drug of all, selling drug of all time. You're talking about billions and billions of dollars that are going to pour into R&D and really accelerate genetics technology and longevity and biotechnology. And that's just the tip of the iceberg in terms of other things that plagues or pandemics or wars tend to change in the world.
Okay. And then one of the other 4 things in there, the impact on genetics, rapid ascent of AI, privacy versus centralized control, remaking of work. Let's just jump. Let's take the second of those, or whatever that was, the rapid ascent of AI. What's the relationship between coronavirus and the rapid ascent of AI? And we'll use that as a bridge to get into sort of where we are in AI.
Well, if you look at, Moderna is actually one of the most interesting companies on the planet, and they've kind of integrated machine learning into every single aspect of their platform. And they actually started with a digital first philosophy. If you look at a lot of the other pharmaceutical companies out there, they're trying now to catch up and retrofit these very paper heavy processes, whereas they've got a predictive analytics in their risk assessment of their trials. They've got it in the design of the drug, and they're using it very much in the kind of centaur way that I always talk about, which is, a lot of people talk about, AI is going to do everything. It's going to take over everything. It's like, look, the AIs in their current iteration do one thing kind of really well, and that tends to be big pattern recognition. Humans still do a lot of insight and creativity, so I always see them kind of working together.
Right.
And Moderna said it the same way. Their chief of sort of analytics and said, look, we have people doing the things they do best, we have AI doing the things they do best, crunching through big genetics databases for drug discovery, or repurposing drugs, or for finding a unique set of genetic code, right? Instead of having, imagine like, I get the genetic code for the coronavirus, or the coronavirus 12, or whatever version is, whatever horrible thing's going on next.
Yeah.
And I go, well, what's the most unique part here? Okay, well, I can comb through the Gattaca, and look for it myself with 150 people, or I can set the machine learning algorithm to crank through it and try to find the most unique parts to focus in on, right? All of a sudden, these kinds of things. Or think about something like what DeepMind did with the protein folding. Look, you've got the Cas folding, contests that have been going on for 25 years, I think. This started in 94, and the top team had something like a 41% like success ratio at predicting proteins, right? So they come along with AlphaFold 1 and have a 56 or 57%, and then all of a sudden 2 years later, AlphaFold 2 has a 97%, across the board. That's an incredible leap. And then you look at something like them releasing the database of 20 different species. There's something like 200 or 200 to 400 million known proteins on the planet. We've only been able to predict a small fraction of them. In doing each one, you literally cannot solve this problem any other way. You cannot solve it with anything but AI. You cannot brute force it with kind of classical handwritten code. You can't brute force it with experimentation. X-ray crystallography and all these other things sometimes take months to years to finish a single protein. And they
Right.
only are going to get funded when they already have an insight that this might work for a drug interaction,
Right.
right? So they might miss, 100,000 proteins that might have actually been better targets. Now all of a sudden you start with this unlimited database that's accurate down to the atom for a huge chunk of them. And now you can like run a machine learning algorithm on top of that to go hunt for what might be the best drug interaction, right? So all of a sudden you've accelerated the ability to do things, and it's really just going to be turtles all the way down.
Yeah. I love that phrase, by the way. That's one of my favorite phrases. It's turtles all the way down, son. Look it up. If anybody's listening to this, look that story up. It's very funny. I love that you know that phrase. That's really one of my favorites. All right. So with that, I want to sort of shift focus on, moving into AI. So the goal of this podcast for me has always been, when I got into the field, which was only 3 years ago, pretty much at this point, getting into it 3 years ago and going, oh, this actually looks like it's about kind of where cloud computing was 13 years ago when S3 launched and Amazon started developing Amazon Web Services. I feel like this is now the sort of implementation phase. We're actually putting stuff into production. It's doing real work. And so as we get into that, I think an interesting question to sort of help people who don't really know the space is just like, where are we? What does the next 10 years look like? What can it do now? And what will it be able to do in 10 years? I know it's a broad question, but I think just helping give people a grounding who really don't know the space and really don't know the state of the art. And I think what you're touching on with the protein folding, for example, which is like doing very complex analysis for proteins, which we couldn't do before and now we can do, right? That's a good example of that. What else do you see that's kind of on the horizon? We can see it pretty clearly in the next 5 to 10 years. And where are we in that arc?
We're definitely at a tipping point. Look, if you don't know the history of AI, you know that for 50 years it didn't do much, right? And it's not theoretical physics. You can't just write down the math and go, well, we promise it'll work in some way out in the universe, right? It's a practical field. It has to do things, right? In real life, it has to spot digits or understand language or pick objects out of an image or whatever it is you want to do with it.
Right.
And the fact is, we had the theory for many years, all those books, that you're talking about. I had all these old papers with, perceptrons and all this, and Lisp, and thinking like, yeah, it's amazing. And like you said, it didn't go anywhere. So I went to, IT, right? IT consulting company for many years. And then all of a sudden, like you have this thing where it's the main problem is they just didn't have the processing power and they didn't have the data sets. Right. And then all of a sudden you have the rise that you want to talk about the interaction of systems and how systems put pressure on things. All of a sudden you have this kind of thing that changes something. Like when you get the printing press, all of a sudden, the Greek classics come out of like antiquity. They come out of the 5 copies that are sitting in a monk's cave somewhere. And now all of a sudden they're getting printed and people are reading them and going, whoa, this is mind blowing. Changes my thinking on things. Let's all of a sudden, all this stuff you couldn't print before because it was super controlled and required a lot of effort to do, all of a sudden now you're printing all kinds of stuff and you're accelerating knowledge. So the same kind of thing here, when the internet comes out, all of a sudden you start getting these huge data sets. That's number one, right? Internet scale data sets. And the second thing is you get these graphics chips, right? Which, like with the rise of video games, everyone thought it was kid stuff. Well, who's laughing now, right? And you look at it and like, it's all these little chips that are basically processing in parallel, which turns out to be awesome for matrix math. And you have kind of the seminal tipping point, which is, AlexNet in 2012, right? Where they basically, a student of Geoffrey Hinton. And remember, before this, Geoffrey Hinton and a few others are trying to keep the lights on with like one grant from the Canadians, right? For a decade when everyone's telling them it's nonsense and it's not going to work, right? So they keep the lights on. And all of a sudden, one of his students does AlexNet and object recognition dropped from 30% error rate to 15% with AlexNet. The next year, everyone's using neural nets. It drops to 7%. 2 years later, they close the contest because it's better than human beings, right?
And for those who are not familiar with AlexNet, that was everyone refers to that as like the ImageNet moment in computer vision, right? So this was using deep learning and deep neural networks for them to identify cat images, right? That was fundamentally the whole data set that I think Fei Li was one of the founders of that whole setup, right?
It was more than cat images. Yeah, Fei Li was the founder at Stanford, and there's 1,000 different objects that you have to recognize in the original ImageNet. And they were, AlexNet was one of the first sort of breakthroughs in that point and said, hey, this can actually work, right?
Right.
So,
And that was around
so you
2012, right? And that was the
this
first
2012.
big sort of like the big moment for deep learning because, as you said, Hinton and all the folks who were pushing on it for decades, everyone's like, this is nice theory, but it's not going to work in reality until the compute
That's
and
right.
storage capability was there and suddenly it made sense.
Right, and now we've had kind of like a rapid evolution in the last 10 years. You've had
Right.
all those folks getting plucked out of academia and $1 million jobs and moved into big tech. You've got these kind of internet scale companies where they basically can't Facebook, for instance, can't track all of the different images. You can't hire 300,000 people to look at every image that's posted. You need artificial intelligence to do it. It's
Right.
Again, there's certain
Comes
problems that
back to
can't be
scale.
scaled.
Right.
Comes back to scale, right?
Right.
Or you look at, they had Neural Translate was at Google, where essentially like they built a rule-based system that was pretty good. Like you could put in some standard phrases and you're welcome and good luck and get those kinds of things with 100% accuracy. But go put it in Hemingway text and try to get something coherent out the other side, and it's like, not so much, right? Whereas all of a sudden, Neural Translate takes it to this incredible new level where they're basically they're basically using encoder and decoder, and they're taking all these pre-translated text, usually from a data set from the UN, right, where they have professional translators doing it. The neural net's studying both sides of it, and all of a sudden now is making the language sound much more natural. Now all of a sudden you have these real-world applications that are happening. The thing is, though, it's still very early in the space. Most of the technologies sit in the big FANG companies. It's been in the military. It's been in governments, right? In China, it's been like awesome at productionizing it, mostly for city level things and facial recognition. I just went to the airport for the first time. I hadn't been back to the States in a few years, and global entry. I used to have to type in a few things and answer a few questions, and now it just says put your face in there, and it goes, "Here's your sheet, Mr. Jeffries." It's
Right.
like, okay, so apparently I'm in the facial recognition database.
Yeah. But I see that as kind of two waves, right? We've got that 2012 wave that comes through, which is around kind of image processing, let's say,
Yep.
and deep neural networks for image processing. And now we see this whole wave of natural language processing, right? All the GPT-3s and all the equivalents and the global equivalents in China. There are competitors to that. They're apparently even bigger. So this new wave coming through of language and translation, and that's now pushing through the system, as you would say.
Yep. But we're still in the early adopter phase, and like we've got to come down. If we look at that curve, that kind of diffusion of innovation curve that's in that book, is a fantastic book. It's very scholarly, but kind of talks about what is innovation, ideas and technology, and how do they disseminate in a social network. In other words, how do they filter into society? What's the resistance that they face? Who's the most likely to adopt it first? Why? And who adopts it late? We're still in that early adopter phase. So we're out of the pioneering stage, but we're in the early adopter phase where it hasn't trickled down to every single business. It's still at the point where it's like the iPhone 1, right? But you try to explain the iPhone 1 to someone when you get it, and people can't imagine Spotify and what Instagram is, and
Right.
all the things that are coming. You're going to be able to listen to music anywhere, and you're going to share photos all the time, and you're going to chat with your friends on the crypto. They're like, what? People, look at that. They're just not going to get it. The thing has to become ubiquitous enough with early adopters who understand what the pioneers did and start saying, look, let's start using it in this space, in this space. And there's a lot of failures. There's a lot of things that don't work out. And then the kind of naysayers are always come out of the woodwork at that point and go, well, the technology will always fail, And you're like, well, actually, like these 3 use cases are like amazing. And all of a sudden, it just takes off. And then you get to that early majority phase where everybody just uses it without even thinking about it, right? And we're going to, over the next 10 years, in 20 years, we're really going to get to is something where AI becomes much more ubiquitous in society, and AI itself is going to continue to develop over the course of that time into more general purpose and transfer learning systems, right? That's where a lot of the research is happening now. Right now, it's still very single purpose. You could train a machine to be the best Go player in the world, but then if you retrain that same neural net to like recognize cats, it'll forget everything it knows about Go. So there's a lot of research in saying like, how do we have multiple neural nets? One's a giant one and one's just a quick learner, and you freeze certain nodes in there to learn the old task, or you average them out so you only have the 5% of the ones, and you can continue to add tasks that it understands. These are the kinds of things that are going to develop over the next 10 years. But right now, it's already enough to have something that knows how to do something really, really well specifically. And we're going to start to see that disseminate out of the big tech companies into almost every company on the planet. It's going to touch every single society and type of business on earth.
So let's now really focus in on the development of that kind of technology, so the model building, right? So there are two things that I want to ask you. One, the first is it sounds like you would agree with this sort of premise that AI is really eating software. Like, what is it? Software was eating the enterprise, and now we're saying a lot of folks are like, AI is eating software. Most things are going to be AI and not really hard coded software. Agree or disagree? Let's start with that, and then I'll go to the next one.
I'll say I partially agree with it. Look, what I think that there's things that AI can do that naturally traditional software can't do, right? Like we couldn't teach traditional software how to recognize cats or recognize a tumor,
Right.
right?
We tried, but the rules got too complex too fast, and it just didn't work.
It didn't work, even with spam, right? We don't think of the spam detection as AI, but that is, right? It's Bayesian filter.
Bayesian filters, right.
That's sort of early artificial intelligence. When we try to do rule-based systems, it just was like a towering inferno. You know, it would just come crashing down. It didn't really work very well because humans are very ingenious at getting around blockades, right? So, you know, my thinking is I don't like the idea that AI eats all software, right? Because I think there are certain things that like Elon Musk says, look, I discourage the use of machine learning in a lot of applications because sometimes it's too complicated or you don't need it, right? It's like if I'm writing a login. Right, I'm writing a login system. I don't need an AI to write the login system. You can go back and look at 50 different examples out there.
Yeah, exactly.
Right. So just do those things. But there is a whole series of new problems that we just haven't been able to solve with traditional hand coding. We've reached the limits of that, and those are the types of problems we're going to be able to solve now. And that's what's really exciting. You look at something again like the AlphaFold 2. That is a problem you literally cannot solve through brute force. You can't solve through hand-coded logic, but you can solve it through AI. There's a number of problems that fit into that domain, and it's going to be very exciting to see those start to take shape over the next 20, 30 years.
So software development lifecycle is very well known, right? For the last 20, maybe more years, maybe more decades, but we've been building these systems and processes and tooling and language and kind of a culture around software development. And so I think most people in most sort of Western, let's say modern technical environments would go, yeah, we all kind of know what you mean when you say software development lifecycle. We know what you mean when you say continuous integration, continuous development, agile development. All of these things are kind of known. The processes and the tooling and the tool chains exist now after 20 years. And you were a bit, you played a part of that being over at Red Hat. There's a current focus right now, which I want to get your opinion on. I'm not personally a fan of this kind of like focus on MLOps is the same thing. Because to me, MLOps is really just DevOps, except pulled forward to the model world. So what I mean by that is it's moving from dev to production, getting the thing out of training and into production, which is a tiny subset of really the model development lifecycle, which is, what is my business problem? Should I use machine learning to solve it? Okay, well, what algorithms, and can we train the models, and do we have the data? Yes, we've trained it. Now we can put it into production. Now, is it still working? And, is it doing the right thing, or do we need to retrain it, or do we need to decommission it? To me, that's the full model development lifecycle. And I think that the software development lifecycle and the model development lifecycle are two systems that sit side by side. They're parallel inside your product development lifecycle, if that makes sense. Does that framework make sense to you?
It makes sense. Look, first of all, the term MLOps though is evolving, right? It, like any term when it comes to we tend to think of terms as fixed, but that's only because the term is fully baked by the time it comes to us. Whereas we forget that there's a period of time where people are trying to come up with the correct term. There are terms that don't work, and then and then they try to say, well, is this? It only applies to this. Or I am of the opinion that machine learning operations, and that's the way I think of it, is everything from sort of the data ingestion all the way to putting the model in production, monitoring, managing it, auditing it, right, in every stage in between. And there's also, I think you were hinting at it in the earlier phase, and I'm sure we'll get to this anyway, but there are very different steps between the classical development lifecycle and the machine learning lifecycle. And the problem is a lot of the early tools tried to just port over the DevOps lifecycle.
Right.
And there are fundamentally different steps that we're missing. When we're talking about machine learning operations, I think it actually is 100% goes through the entire lifecycle. And we forget that this term is still being defined, right? A lot of times we inherit a term in life and we think that it's, it always meant that thing. It's fully baked. But the fact is, in the early days, there's a lot of people trying to come up with the correct term and then define what that term means. And that's part of the evolution of it. That's where we're at now. So for me, machine learning operations is from all the way from data ingestion all the way to putting a model in production, monitoring, managing it, and auditing it, and kind of rolling back through. There's a lot of stages in there that don't match with the traditional DevOps and traditional, hand-coded logic lifecycle. There's no analogy to the training stage, for instance, right?
Right.
You generally don't have things like synthetic data in there, right? And there's also a different focus. Like I think one of the failures of many early projects was just trying to port over that DevOps focus. So you look at something like, Kubeflow, for instance, and it very much is a thing that has a focus on kind of a DevOps mentality. It's almost like hand-coded logic and data is secondary.
For somebody who doesn't know what Kubeflow is, just what's the 30-second version of that?
The Kubeflow is designed to be kind of an interoperable Gloom framework for machine learning that unites a lot of different components on Kubernetes-based platforms. But I think it's mostly developed into basically a Python pipelining system, right? And I think it had a broader kind of vision, but I don't think it quite hit that mark. Maybe it will in the future. Open source projects can evolve, and I don't like to say anything bad about open source projects. I think it's amazing when people come together, but sometimes it doesn't work perfectly the way you initially designed. And I think what they're trying to build, and what I want to build with the Artificial Intelligence Infrastructure Alliance is an abstract data factory, a Kubernetes of machine learning at some point. I think it takes 10 years to get there. The reason is because if you take you just try to take the template that you already have and port it over, it doesn't work.
Right.
And it doesn't work because if I have a hand-coded logic, for instance, like we talked about earlier, I write the login and I write all the rules for that login, and the data is secondary. I only touch the data for the username and password,
right?
And it's secondary. And so naturally, the original coder's idea is to mirror that process. The problem is, in artificial intelligence, the data is primary, and it learns from that data, and 80% of your time is spent corralling that data, pulling it out of 12 different sources, threading the RBAC control, transforming it into a different format,
that data.
Normalizing it, cleaning it, getting it out. And then even Angrignon talks about this a lot, right? Where, you sometimes you throw 5 different algorithms at it, you get a 0.2%, better difference. And then you go back and you realize, well, the bounding boxes, we had 40 guys, doing the bounding boxes. And all of a sudden, they all interpreted our heuristic a little bit differently about where to draw the bounding box. So let's go back and clarify that, and all of a sudden have 30% of them redone, and all of a sudden now we've got 20% better performance, right? So there are all these stages that really just don't exist. And what you have to do is you have to go through these kind of pioneering systems who run into these problems and just run right into the wall of these unexpected problems. Right? Like the team at Uber, they built Michelangelo and they go, well, this is going to be the general purpose system that does everything. And what they found is it did the 2 things they designed it for and nothing else. So they basically broke it up, into 50 other projects, right? And half the guys left and started Tecton, and a feature store, right? It's like, so these kinds of things, you don't know you have the problem until you run into it. It's an unknown.
Right.
And then the tools start to develop. So you really can take inspiration and ideas from a lot of the old models.
Yeah.
There's a whole series of brand new tools and paradigms that have to develop in this space. And that's where we're in the evolution of right now.
Yeah. And I think, and again, to sort of summarize and simplify that. So it's like we've spent 20, maybe it's 30 years developing these systems and processes and approach and kind of sharing that information out through the developers of the world. And everybody sort of speaks relatively the same language, and they all kind of know what the tool chain is constructed of, which parts exist in that tool chain. And now they say, great, we're going to do some model development. Well, let's just use the same process and kind of use the same language and try to build some models with it. And it doesn't really work. And so everybody's in this process right now of going, okay, well, what is the correct tool chain? What are the components that we need? What are the processes and the process steps we need to take? And how do those sort of loop back on each other? And what does this look like? Because this is a unique and different process and system. It only is like the other thing in that it is a system that has some inputs and some outputs, but everything in the inside is different. So we sort of like need to figure out those components. And that seems like where we're at right now. So stepping back before we dive into sort of AI Infrastructure Alliance, any type of big enterprise system, I'll keep using enterprise because they have the most complex IT stacks. Any big system like that, there's always been this sort of age-old debate. Do we go, end-to-end system from one vendor kind of, let's say, the NetSuite model. I always like to use that example in the early days, where they're like, we do every function in the enterprise, but we do it like 3 inches deep. Versus the Salesforce model, which is, we're just going to do CRM. 20 years ago, we're going to do CRM. Only going to do sales. We're going to go super deep, and we can work from one user up to 100,000 users, right, of sales folks. And then they sort of work their way out. So they went, mile deep and an inch wide, and NetSuite did an inch deep and a mile wide. And maybe to simplify that, it's kind of like, do you do the end-to-end thing, or do you buy a bunch of components, best of breed components? So suite versus components. That's the age-old thing. And I think you and I probably agree that it's not always either or. Sometimes it's, yeah, we buy an end-to-end system that sort of is the backbone, and we also have these components that go deep in certain areas. So it can be really additive. Give me your thoughts on that general set of patterns, and then let's dive into sort of where AIIA fits into this.
Yeah, so at this stage in the evolution of infrastructure, the only end-to-end solution that exists is in the minds of marketers.
Ooh, that's a contentious statement. I think Google's Vertex team and maybe the SageMaker team and the Azure ML team might take issue with that.
They might, but their marketing teams are the only places where those are 100% end-to-end systems, right?
All right.
And look, this is a fact. Look, I mean, I've had research teams looking at all these different platforms, right, and running them through their paces, and separating the kind of marketing hype from reality, right? And I have no doubt that they have the aspiration to become end-to-end systems.
Yeah.
But where you really look, they are actually a series of kind of bespoke tools that don't always perfectly play nice together, and they do some things incredibly well. I mean, look at something like Databricks and Spark, right? Okay, a fantastic platform, one of the early pioneers in the space, but also understand that Spark was created before AlexNet, right? So and you're retrofitting a lot of machine learning into that space, right? And there's kind of this onset now with their kind of data lake, for instance, which I think is fantastic in many ways, but it's also this idea that it unifies structured and unstructured data. It's generally not true. I think there's one example of unstructured data on the entire site, and it's images, but there's no audio and video. And why is that? Because it's essentially a database structure under the the Paraquet file, right? And you can only shove so many giant videos for editing or 300 gig satellite images into that space. So you need some kind of file-based system to be able to deal with that unstructured data. And yet, structured data is incredibly performant in databases. And so using them for log prediction and churn prediction, these kinds of things are fantastic.
Right.
But let's not pretend that it's also the unified solution for unstructured data, dealing with doing deep fake lip syncing for audio dubbing, like we're starting to see happen now, or crunching through satellite images.
Right. You wouldn't process a trillion images. It's not designed for that.
Right, you're not going to do it. And again, so the marketing tells you that you're able to do that. And if you look at most of these systems, I'd say most of these systems are almost 100% focused on structured data, right? You look at 90% of the monitoring systems out there display what's easy to display in structured data.
Right.
You look at most of them have a database backend, which is fine. But you have all these interesting things. You have genomics, you have audio, video, you have giant high resolution imagery, and you have unstructured text. By the way, 80% of the text out there is unstructured. So you have a whole series of tools out there that claim to be sort of end-to-end, but really you don't have to dig very deep to understand that it's not the case. So I think you're really always going to need, you could have one of those systems as a backend, but if the team sort of believes, and maybe it's enough for just the use case you're doing. Maybe you're only doing housing pricing prediction or churn prediction or whatever. You only have structured data. Great, you're fine. But if you want to then start to expand into kind of multiple other layers, you're in trouble. And I think one of the things you talk about with your kind of consulting firm is you want to build for the next decade. And to do that, you want to have a number of solutions that a lot of different teams are going to be able to utilize and standardize on, not just a single solution. And what ends up happening is a lot of times you hire one data science, data engineering team, they pick like the one tool for that job, and then they kind of expect to generalize out to the other ones. And it's just like AlphaGo being retrained on cats, right? And it suddenly doesn't work, right? So, my thinking is you have to have a more comprehensive strategy. You're going to have a lot of these different pieces, and frankly, you're going to have them for a long time. There's not going to be a VMware in this space for 5 to 10 years that's able to kind of, because the field is still developing, like we talked about earlier, right? There's we don't have the O'Reilly book on the best way to develop synthetic data, right? We don't have the O'Reilly book on the best way to do auditing and compliance for an auditor who wants you pulled out of a facial recognition database or wants to audit 5 years of inference predictions for bias.
Right.
We don't those tools don't even exist, but they're going to have to exist. So
They're all being built right now.
Yeah, they're all being built right
you
now.
often say, what, there's no lamp stack for machine learning.
There is no.
So first explain lamp stack and then explain what that means in this context, again, for folks who may not be familiar with that. You lived that life.
Right. So yeah, now I'm dating.
You forget what you know.
Yeah. So I mean, look, in the early days of the internet, right? All of a sudden, everybody's rolling their own solution. They're pulling from one of 20 different web servers. They don't know which language they're going to use. Like they have to build their own deployment system. They have to build their own system for how they manage their website and what it looks like. And then over the course of time, right, you start to get these kind of general solutions to this problem. So the LAMP stack was one of the first ones. It was Linux, PHP, Apache, and MySQL. So that was your database, your language, your web server, et cetera. And all of this, and that enabled the development of other types of technologies. Once you have these foundational technologies that most people are going to look to as the default solution, the first solution,
right?
You move up the stack to solve other problems. So you get something like WordPress, which now runs 50-60% of the words, on the thing. And then from there, you get a drag and drop editor theme that sits on top of that, where now like a chucklehead designer like myself can actually, pull together a reasonably decent looking site without, knowing how to write XML and a bunch of other code on the back end to make it beautiful. Right. And so these types of things can't develop without the foundational technology. My sense is there's no LAMP stack for artificial intelligence. And what we're going to have is Darwinism over the next 5 to 10 years, where a lot of people are going to compete. A lot of people are going to, there's a lot of money pouring into the space. You got billion-dollar valuations for, people writing how to sneeze in AI, right? And all of a sudden, it's like some of those are going to obviously collapse, or they're going to merge, and you're going to have. I always say in the Infrastructure Alliance, we'll talk about in a minute, is we might as well all work together now because we're all going to be working together anyway, companies.
We're gonna all get 5 of us are gonna end up being acquired by the same parent company or something next week probably, or next month.
Right, and one of the startups runs out of money, it fails, and we end up in another one, and
exactly.
or you have an idea for one of these spaces that nobody took seriously, and you start your own company, and all of a sudden, this is how it works. When you look at the early phase of any technology, they look at the car industry, right? And they go, well, there's like 4 or 5 car companies in the world. Yeah. In the United States, there were about 100 in the early days of when Ford and all that stuff.
There were actually several hundred.
That's right. And they all consolidate down. And they could be there for building windshield wipers, and just right. And yes, you have a lot of companies that now supply the big companies.
Right.
But it took a long time for those kind of companies to consolidate down on the correct solution, the correct design pattern for building a car. Same thing's going to happen in artificial intelligence. We're going to take a while to converge on that correct design pattern, and it requires a lot of failure. Failure is not a bad thing. Failure is the sign of progress. It's a sign of evolution. It's how we learn. It's how economics grow. It's how industries grow.
And so let's talk about the AI Infrastructure Alliance. So what is it? Who's in it? And sort of what's the intention here, and how does it tie back to everything we just talked about?
Yeah, so the AI Infrastructure Alliance started as just a simple project, a simple bullet point where I thought, I'm going to build an industrial alliance, and now it's taken over half of my life. I didn't know what I was getting myself into, but it's
because you needed more things to do, right?
Yeah, I needed more things to add to my resume, so I had to my time. But initially I thought, okay, well, this is an early adopter space. I want to raise awareness in the space. I want to get some articles in the news. I want to get people talking to each other, and so I kind of went to some early days. I put up a website. I went to the big companies in the space that I had contacts were, shall remain nameless, and I said, look, I want to raise awareness, I want to do all this. And they go, great. When does the API Standards Committee meet? Where's the 86-page legal diagram? I said, hang on a second. I want to raise awareness. I want to. So they didn't quite get it. So I had to kind of
wait. So the conflict was you sort of wanted to build community, and they were more like, let's have this more as a standards conversation.
Right, or they that's the way the large companies, which are fully developed, had already see it, but the industry wasn't there yet. You're not there to. We're not at a point
too
where
early
we build the sort of universal API. We need to bootstrap our way there.
Got it.
By getting all these vendors talking together. So I started dialed back, and I started at Pachyderm, where I work. I started working with Determined AI and Intelligent and some others. Put them on the website. Then I started working very closely with the MLOps community, which is fantastic. A lot of data scientists, data engineers in
Mm-hmm.
Slack, having wonderful conversations, sharing information, learning from each other. And then it started to snowball from there. Now there's 62 members in there. And
Wow.
what's been amazing, it's been great. I mean, solutions integrators and people have had to even hold back. And we just filed the paperwork to turn it into a 501c6. And it's moving to from an ad hoc organization to a membership dues organization. We hope to be one of the premier artificial intelligence organizations in the world. We're going to focus on education. We're going to focus on white papers and standards and bringing clarity to things. We're going to focus on events. And there's a whole bunch of things that we're really excited about our ability to do now. And we got to modernize the website. The website's still looking a little old, but it's look, I'm not ashamed of our beginnings and where we started. And what I've been excited about is the micro alliances that have started to happen. There's again 62 companies in there. A lot of those companies hadn't heard each other, weren't even talking to each other. And then all of a sudden you've got a dozen white papers that have come out of it, 3 or 4 go-to-market strategies, 5 or 6 engineering teams in different places cross-connecting, right? It's like, I think Algorithmia did papers with 6 people. Pachyderm has done, papers 2 or 3. And all of a sudden it starts maybe as a simple toy example, where it's both sitting in your GitHub repo, and then it moves to something, much more comprehensive, right? I think, Pachyderm, for instance, and Seldon's teams have developed to a great relationship in terms of the sales team, engineering, and is working strong on a go-to-market strategy. So, we really want to continue to foster everyone kind of working together and getting out of their little silos, right? And starting to think about how to solve these problems. You can't abstract out the kind of the eventual solution until teams start working together, solving problems, integrating, and figuring things out. So I'm excited about what we've been able to do so far. We've been able to get a lot of press out there. We've been able to become kind of a household name. And I'm excited about what the kind of next level of funding is going to be able to do for us and where we'll be able to go from there.
I think you or somebody in your crew called this the Rebel Alliance, or was that somebody else writing about this? Maybe did you use that phrase?
They quoted me and they put it in. Yeah, I think.
Okay, yeah. So this is like all the, or to use the other, what is it, David and Goliath? This is all the Davids, trying to say, hey, we're going to fight back against the Goliaths. Is that really what it is, or is that maybe a gross oversimplification and maybe not even appropriate?
I mean, look, simplifications are useful, right? It helps you understand things at a level. And the fact is, there are more kind of small and mid-sized startups in there, right? I think there's several $1 billion in funding within, like, across the groups that are in there at this point in time, which is crazy, right? And there's some fantastic solutions integrators as well in there, and there's just some hardware spaces in general purpose platforms, but I think initially I thought it was kind of like us against kind of the big 3 clouds, right? In terms of, if I'm being honest about it, right? Yeah. But kind of that end-to-end sort of thing that they're sort of kind of promoting. I think the cloud's an amazing innovation, and I think those tools are wonderful, and I think they actually have a great deal of purpose. But I just don't buy the fact that they're end to end, right? And that they do everything, and they eventually might, once they've consumed 3 or 4 of the projects in the IO.
Then they'll have the depth, because right now they sort of have the breadth in specific use cases with specific data, but maybe after they acquire more and integrate more, they might have more depth and more use cases and more data types, etc.
Right, and think about, like, the way these projects develop, right? You get 100 open source projects and 50 different proprietary solutions to solve a database problem before you converge on Postgres, MySQL, Oracle, and and now in the modern day, and now in the modern day Snowflake and Redshift and these types of, in MongoDB, right? But there are lots of other people who didn't quite make it. So, I mean, does anybody think that, like, the SageMaker feature store is going to be the final feature store that everybody in the world is using? I don't think so. Again, would Kubernetes have become the Kubernetes if it only ran on Google, or the fact that they open sourced it and pushed this wider community? So now the Kubernetes runs on even their rivals, right? It runs on Azure, and it runs on AWS, and it runs on-prem and in enterprises and whatever else. And it's become this kind of general purpose factory.
Kubernetes was, just to take that tangent, I think Kubernetes was such a great strategic win and strategic shim, in the sense that they're like, hey, we're losing the cloud war. And this is being Google, we're third place and not really catching up. So let's just make this universal abstraction layer and make it run on absolutely every infrastructure. And once people are on top of that, then we can say, oh, so look, it's so easy to come over and move your stuff onto our infrastructure. Genius long-term move, I thought.
Genius long-term move. And by the way, they played to their strengths, right? They had Omega and Borg, which they've been working on, like internet level scale, like managing hundreds of data centers level scale. And they've been pushing containers. They created containers long before Docker. They were pushing 2 billion containers a day, right? So they had already come up with a lot of these design patterns with Omega and Borg, and they worked through those. By the way, Omega and Borg still running inside of their house in addition to Kubernetes. Those were evolutions of how they solved this problem. Remember, we were talking about evolution over time, and you don't know what you don't know. And then after you've solved a problem, you go, geez, if I could go back to the drawing board, maybe I would have solved these things in a totally different way. But you've got technical debt. So then you create a new system. And then you go, well, if 5 years later, you go, maybe if I'd had this foreknowledge, I could have gone back, and all of a sudden you get Kubernetes. So the same kind of thing now is that you've got a lot of these systems that are going to develop. It's way too early to say you've come up with the complete final system when half of the protocols and like design patterns haven't even developed in the space. Are still early phases, right? It just doesn't make any sense. So the AIIA is really about helping foster that canonical stack, foster that interoperability, foster like a competitive bazaar. The way I think about it, and this came out of my Red Hat days, right? The cathedral versus the bazaar kind of thinking, where you have these kind of top-down military-style organizations that existed forever. Like, the founder tells everyone to do, everyone shakes in their boots, and, nobody wants to report up to the founder that that's a dumb idea, so you better hope your founder's really smart. Versus the bazaar effect, where, like, it's a lot messier, it's more organic, it takes a long time to develop. You look at a lot of open source software, the interface is hideous at first, it's this weird design by committee, and then all of a sudden it starts to come together and blows past kind of the proprietary version.
It's the Solaris versus Linux story again.
Exactly right. Originally, Solaris was infinitely better. I mean, still things like ZFS blow away kind of Btrfs and the other copy and write file systems that have come after it. There are still things that it does better. But when you talk about a system that runs on any kind of hardware, that can be run on a tiny piece of hardware, to something that powers the stock exchange and rockets to Mars, Linux has it beat hands down, right? Because of that kind of messy development cycle.
Right.
So it's not just open source, that's development, that's the evolution of these kinds of things over time, right? And that's really where we have to get to in this space, is that there's going to be more of this evolution, and anyone who thinks that they kind of got the end all be all solution now, it just hasn't developed far enough along. You can't possibly have anything you're not going to throw out in 6 months, right? Even if they're swapping it out secretly on the back end.
So let's talk about the blueprints and the design patterns, which kind of leads into the blueprints. And so one of the issues that you and I think one of the reasons we bonded on our first call is sort of this whole idea of, like, you and I had both thrashed pretty hard, maybe you even harder, on sort of the makeup and the scheme and the structure and how do we name these things. And I always go back to the 10 blind men and the elephant. Like, what is the elephant? One guy says it feels like a stick. Another guy says it feels like a wall. Like, they're all looking at different parts, but when you add it all together, you get the elephant. And so I think you looked at a lot of the work that was out in the field. I looked at a lot of the work that was out in the field, and I kind of just kept cross-referencing until I could get to my version of what I think the systems look like and what the language is. You did the same. I love the work that you did on the blueprints, but before we get to the blueprints, why were the existing things not enough? There are a million market maps. There are lots of listings of companies. Why are those things not adequate? And why are they not enough to make sense of the space?
Well, I talked about it a bit in the kind of rapid evolution of the canonical stack article, right? And that is that most of the times the people are putting out architectures for someone like Google who built their own in-house architecture. And what's interesting is that and then everybody just references the same graphic that they put out. But when you really start to, what nobody did was any critical thinking in looking at those things, right? And they go, can I just replicate this? And it's like, well, you look at the Google graphic, for instance, and what I notice is missing is there's no data layer in there, right? Like, well, where's the data? Well, they've got a global planetary file system that unifies all of their data across, 100 data centers. Do you have that? And if you don't, then you probably need to have some kind of data layer in your diagram, right? And so that's number one. The other thing that I was sort of reacting to, and I'm sure you got this slide, is the NASCAR slide, right? So and in marketing, they use that as a positive. I use it as an intensely negative way, right? And that is, here are the 87 categories. Yeah, this type of thing. And by the way, I just saw one published the other day. People love this graphic. They keep publish. Every marketer comes up with this thing. It's super easy to do. You know what you do? You come up with 86 categories of machine learning, and you fit 500 logos neatly into each one. And these are ridiculous. That like the concept of this thing that like first of all, most of these companies don't even exist. This one's from like 5 years ago, right? And Siobhan
the die-off has already happened. Yeah, half of these companies are already going.
Siobhan Ellis is brilliant in machine learning. So, and the work she was doing was pioneering, but this is pioneering 5-6 years ago. It's ridiculous now. And people still do it. And it's like, people don't cleanly fit into these categories. They move into a lot of different categories. And so that was kind of the point, of saying, look, first of all, can we distill down the stack? After talking to dozens of CEOs and seeing all these product demonstrations in the AIIA, researching all the literature and going like, what are the common abstractions of what people are spending their money on? What are they, what are they investing in? What are they working on it? And what are the overlaps, right? And what you end up seeing is kind of like, are you able to pull up those the blueprint graphics? I think if you pull up the graphics there, you can start to see that there's kind of a common design pattern that goes from data ingestion all the way, to monitoring. And then what's more interesting is, instead of saying like, okay, somebody just fits across, their logo neatly fits into the data engineering pipeline and nowhere else, the fact is actually they cut across multiple parts of the pipeline. So if you go to a different example of one, right, of like, this one is a time series based illustration, right? And what's interesting, even we can talk about a lot of things in this, right? In this one, the committee we wanted to represent, and this is a small group within AIIA that kind of came up with this, and I was sort of leading the way with them, but it was a work of a number of different folks. You look at it, and the data stage, we spend a huge amount of time. The training stage, we spend a lot of human time. In the training stage, we spend a lot of machine time. And then if you look at the end stage, right, we spend the least amount of time there, and we have 80% of the tools in that stage, right? The deployment and logging and monitoring stage is where 80% of the tools were dealt, because that fits the design pattern for deploying software that we already understood. Deploying code to a web server and a database and logging and managing, we already understood that design pattern. So people started there. But there's less training, there's less data management and engineering, there's less data lineage and versioning. Those are the harder problems to solve because they're new problems.
Right.
And so, in this graphic, we represented the time series. Now, if we look at how do you color in a graphic like that? Yeah, so in this case, this was one of the members of the AI Infrastructure Alliance, ClearML. The partially shaded equal like a partial support for these kinds of things, or in other words, the tool does bits and pieces of that, but maybe not fully comprehensively in terms of the state of the art. And then a full coloring is saying, look, we do this 100%. And that, right? So you see how one company flows across different parts of the stack rather than their logo neatly fitting into the data stage and meaning nothing else. And by the way, these companies are going to change. They're dynamic things. They're going to expand into other levels over time, right? This is a more classical stack where the team broke it down into these kind of individualized abstracted components. So it's not that the data engineering engine or the experimentation engine or the training engine would necessarily be one singular bespoke piece of software, but it is an abstract concept that's going to exist in one piece of software. We'll do 3 or 4 pieces of this. Right. And so actually we're working on a graphic that's interactive for this. We're going to give to every member of the AI Infrastructure Alliance that they can put on their various partners that they're working with and building integrations with over time, select the colors that they want and say, look, if you click and put these 5 together, so this one's one of my favorites, and ClearML, Fiddler, Tecton, Pachyderm, and Selden, right? And you see where the individual colors come together and show, like, in some cases there's overlap. I think, and this is an older version of it, where there'd be overlap in notebooks with, say, Pachyderm and ClearML and a few other spaces and that kind of thing. But the metadata store has an overlap, right? And then you might have overlap in a few different areas that I maybe didn't capture in this version. But in general of it, you see where there's clear points that certain tools do very well, right, across this abstract, idealized version of a machine learning end-to-end solution, right? And then but you still may need a tool for, robust synthetic data, right? You may need Y data or something like that to fill in the synthetic data part. You still may need a solutions integrator like yourself to go do the fetching of the data from 12 different data sources and transforming it into a standardized format and into the same codec and all these kinds of things, right? And you may need to write bespoke code to do something that and put it into a code repo. So these kinds of things really, we really wanted to be able to show how uh, when you start to piece a lot of these bits together, and maybe even one of these pieces is like your own software that you wrote yourself in-house as you solve a different problem. I was just talking
Right.
to a solutions integrator today, and they built a thing in-house after solving 12 different problems for different companies that they said, well, there's no software that does that. So we built our own for this particular component, right?
Right.
And so how do all those pieces work together? I think that, and there's going to be a lot of glue layers in the early days, right?
Yes.
In 3 or 4 years or 5 years from now, you're going to have overlays and easy interaction points, clean APIs, all these kinds of things that make it easier to stick together. In the early days, you're going to have to piece together some of these parts. The illusion is that you can just go grab, something from one of the big cloud providers, and they've already done all the hard integration work for you. The truth is, though, that most of those are still just bespoke tools that don't really talk to each other all that well.
Right.
And it's a nice idea, but the fact is, for a number of years, we're going to have to be working together to build different best-of-breed tools. And the advantage of that is that you can swap out tools as sort of a better one comes along. Whereas if you're 100% dependent on kind of the glass ceiling limitations of a single provider, well, you're in big trouble. And this is the old.
Well, you get what you get at that point.
You get what you get, and all of a sudden, well, boom, it solves all of our structured data problem. Oh, well, we just moved into, computer vision systems, and we just moved into satellite data. Oh, we were just started processing genomics. I guess we're in trouble. Now we need a totally different system because we can't retrofit this in. And now you're buying two different systems that are totally
two end-to-end platforms.
Right, and now you're managing both of these things, and all of a sudden you got just a complete mess.
Well, and so I saw a recent report. I can't remember who wrote this one, but they surveyed a bunch of tier one leading edge FinServ accounts, like traditional FinServ accounts. And they said that on average, they had 270 models spread across 7 different platforms because each team had developed their own, pulled together their own, built their own, bought their own, any combination of those things, build, buy, borrow, open source, whatever. And they all had 7 different platforms, and these models were scattered all over. And of course, they're going to go through a natural consolidation of that stuff over time. And as they internally probably say, hey, we want more governance, we want more end-to-end oversight across these, and we can't see across all 7 systems, and we can't explain everything that's happening across all 7 systems. We need to be able to have, governance, risk, and compliance is going to play a big role on this in the long run, or in the short run, actually. And so they're going to have to get their arms around those things, and I think that's going to be a forcing function for building more end-to-end systems and having fewer of them.
That's right. And the tools are going to get better over time too. So the tools have to develop over time to be able to allow for the consolidation. And you're right, the other forcing function. I mean, I sat on a tech council recently where a giant bank said, well, I don't know if I can tell you what all of my algorithms are doing in exactly the right way, right?
Of course they can.
And of course, and they would admit that in public, but amongst their peers, they'd admit that they don't have a full grasp on it, and they're working hard to figure it out, right? And you're going to have full kind of auditing and management solutions that are able to kind of get us to the point where we say, like, okay, we need to be able to produce a report that of the inference over time, and whether there were deviations in that, and what exactly that means, and why it made the decisions that it made. And this is going to take a lot of evolution within the space, because sometimes it is a black box, or sometimes it's not as explainable as we want it to be, or you're dealing with 50 different systems and 1,000 models, and it's hard to know exactly what to track. But again, that's part of this evolution. More and more, if there's the market need, more and more of those things are going to start to develop over time.
Okay, so I've spent a lot of my life in sales, so I look at this and I like this idea, cathedral in the bazaar. It's like, what do you say? The hat seller gets together with the spice seller, and they all sort of pitch their wares together, and they say, hey, buy the hats and the spices and the whatever, and we'll give you a deal. And it's like, it's a very cute story, but that sounds like a sales nightmare, let's say, if I'm a buyer. So one of the things that I think I challenged you on early on when we talked about this is, I look at this map that we've got up on the screen. What is this? CFTPS. So that's the acronym of the 5 vendors here, and say, okay, great. Maybe I want to buy that stack, right? It could be that stack. It could be, I'll pull up another one. Let's say this one, or could be this other one with 4 vendors in it. If a buyer wants to buy that, how do they do that? Because that seems very complicated.
I'm not going to lie that it's not complicated, and it's something where I'm actually seeing both from the IS standpoint and from internal from the Pachyderm standpoint, where we've gone to Pachyderm's very much embraced the IA concept, and or else I wouldn't be working on it as much, and they've been very supportive of the idea. And when I look at it, we've gone to market with a number of different vendors, sometimes with two, sometimes with three,
Okay.
and like you have a number of different sales teams in the pitch, and you all have to learn how to kind of synchronize and work together on those things. And
Sounds
sometimes there's
complicated.
different. Yeah, it's complicated. I don't know that it's any more complicated than kind of any enterprise sale, though, right?
Yeah.
It's like, right, when you really look at like the big vendor buying stuff, right? All of these things are kind of complicated, right? It's not, and the complication may be in the fact that you got to go count seats and talk to the compliance and legal team and talk to 50 other salespeople and solutions architects, and you got to do a POC, and you got to go through, right? And so there's a huge chunk just to buy one piece of software,
Yeah.
and then when you look at something like this, like some of the complexity is in talking to a number of different vendors. So that is one of the things we hope to address with the AIIA over the coming years. You and I have talked about that, right? We've started talking about with some of the some bigger providers about being able to provide a lab, right, for be able to spin up a few of these different things. So going from the blueprint to click 3 of these things is a sandbox, right? And then maybe they don't work perfectly, but you get a chance to test across things and play with them, and that's great. And we've started to talk about things like the Combinator project, which we want to bring in, where that it has from a few folks that who've been doing some great work with these Terraform in the back to kind of standardize deployment of some of these things, right? So there has to be
so the goal of that would be sort of one-click deployment of a multi-vendor stack. Is that right?
Right, exactly, right. And then maybe in the beginning days you're only talking about a POC level, deployment of those kinds of things, right? But then you get to something where maybe the providers go, hey, it becomes they become beholden to it, and they go, this is a great idea. Well, now I want to make sure that it deploys on, AWS Azure with like redundancy and backup and these other, and two different geos or whatever. And so I want to define a complex one, and then I want to hand that back to the I want to hand that back to Terraform, I want to hand that back to Combinator, or I want to keep that as, okay, I'm working with these 3 or 4 partners. We've all developed this privately, and as part of the enterprise deployment solution, we share that Terraform. You use this project and it develops. So I think there's like a lot of ways that we can kind of help, solve this problem for folks over the coming years. And that's part of the AIIA itself has to evolve over time.
Right.
As we solve one problem in this space, I solved the problem of kind of bringing clarity. We solved the problem of bringing clarity with kind of the blueprint stack. And then after that, you start to say, okay, we create papers on what does the landscape look like? What does AI readiness look like? What does it mean build versus buy versus just buying a set solution? What is it good for? What, I was talking to a vendor today that said, what, a solution integrator today that said, what would, if I were trying to do the satellite imagery and I was just trying to do churn prediction, what kind of a stacks would I build? Like case-based scenarios of these kinds of, what piece would I,
what problems you're trying to solve, and therefore which stacks are probably the most appropriate.
Exactly. So you start solving it from an education standpoint, then you start solving it at the simple level, at the POC level, right? At the hey, after 3 or 4 deals like this start to get done this way, well, now you've got kind of a more standard process. Maybe you start to unify your paper. Maybe you start to make it easier, right?
And that was kind of a follow-on question. It's like, whose paper is this on? I don't know. Which of the 5 vendors am I going to pay? Or do we have to set up, contract and procurement? Because that's a nightmare. Set up procurement arrangements with 5 vendors now. Is that really how this is going to go down? Because a lot of buyers would just reject that probably.
I mean, some of it, you're going to have an individual software relationship in the same way you've got an individual software relationship with a lot of different vendors now, right? I mean, you don't, when you buy your logging platform, you don't also buy your mail platform from the logging platform, right? You have different support systems for those.
Yeah.
So that's going to be the case. But
that's true.
I have no doubt that there's going to be solutions integrators that come along and start to specialize in 2 or 3 of these stacks. In fact, I've already had a number of inquiries from people going like, okay, well, which ones do you want me to build? Which one should I focus on, right?
Right.
Now,
right.
And the I have to take kind of
wearing your AIIA hat, you have to be neutral.
Yeah. I have to be neutral on these things, but at the same time, like you can start to say, well, look, here's a bespoke solution for the problem you're trying to figure out. Like if you took these three or 4 vendors, right, or you built an MVP with this, right, and so a number of folks are kind of working on that, on the back end, and then all of a sudden those become more kind of integrated over time, and then maybe that becomes the one throat to choke, right? That's the phrase they always use in the enterprise, right?
Right, of course.
In the
integrator becomes the one throat to choke in that case.
Right, and then until eventually, the unified single purpose DOS Uber system comes along, 10 years from now and puts the integrator out of business, or then spawns new integrators, right? That
Right.
come along just trying to manage that crazy ass software that's been developed over that period of time, right?
Right. Okay.
So
So
again, evolution in that space too.
all right, so this is so essentially what you've done is you pulled together. I mean, I can't believe how fast you've pulled together that list of partners. It's grown significantly since you and I last talked, but whatever, 50, 60, 70 companies, whatever are in there, including the system integrator folks. And at this point, you've got whatever, let's call it 50 components. Let's just call them component manufacturers. And you think that you could kind of assemble 3 to 5 of those to build a stack to solve some problem. So then a buyer could then come and kind of get to know the AI Infrastructure Alliance, AIIA. They could get to know all the folks in there. They could hopefully at some point say, oh, well, I am trying to solve these kinds of problems. And maybe there's some kind of educational framework in there that says, oh, if you're doing image or you're doing natural language, you're doing this thing at this scale, probably these are some reference stacks that might make sense. Ideally, perfect world, if you could wave a magic wand, they would have a place, they'd be able to click a button. No different than you started with the WordPress example. You can go to 100 sites now and say, I would like to set up a WordPress site. And it goes click and it provisions the servers and the storage and the Linux and the Apache and the MySQL and the PHP and the WordPress and the themes. Like it assembles that whole stack in 10, 15 seconds, spins it up and says, ta-da, here's your login. And it's ready to go. With a single vendor like a SageMaker and Azure, a Google, or even some of the data robots or the Dataikus of the world, they have cloud infrastructure ready to go. They have sandboxes that you can try. You can literally just log in, set up an account, and start working on. This isn't there yet, it sounds like, but it sounds like you want to get there.
Yeah, it's not there yet, and I like to be 100% transparent of where we're at, right? And again, where I tend to find we are going to get there, and that's part of the reason of turning it into a full nonprofit and taking in some funding from members and getting us to a point where we can help build out these things, because you can't do that with volunteers, right?
Right.
There are limits in terms of like what things you can do with volunteerism. It's you can volunteer to be on the events committee as a volunteer, but somebody's got to be the project manager, somebody's got to organize the software, somebody's got to make sure everybody shows up and has good lighting and like it gets there at the right time and sends out the invites. And
it's not it's not really going to happen unless it's funded.
Right. And so these kinds of things though, but we're confident in the funding, we're excited about it, and we're confident in those next stages. So we're going to work through those bits to kind of get to that phase. In the meantime, the main thing that I say is the mass majority of people are finding the different companies in the AIIA is because they've looked around and the other solutions out there don't actually solve that problem, right? And when I look at something like Pachyderm, we're about to do a huge push on kind of the unstructured side of the house, because I started looking around at all of our customers, and I realized like a huge chunk of them are doing it, right? Are doing unstructured workloads, right? Okay. Video and audio and genomics.
Yeah.
And I thought, well, why is that? I mean, like, why did we win out against other companies in that case? And it's like, well, because generally our software is one of the few that really worked really well with that unstructured data. Right. And so whether, there's a company, we got a case study now coming out of Woven Planet that's doing high resolution satellite imagery, right? It's like each image is like a gig to 300 gigs, and they've carved it up into little chunks, and they're running 30 different pipelines to like do object recognition in one, and then you knit them all back together, right? So it's an amazing use case, and it's just not something you can do with kind of the tools that were built for housing prices prediction and churn prediction and log analysis, right? And
you're not going to throw that into a data robot, for example, and not to pick on data robot. It's a great platform.
Yeah, exactly, and that they're able to do wonderful things with it, and if you're able to do some of the things in one of these kind of singular platforms, great. But what we tend to find is like there's another one another company, for instance, is doing video analysis, and they have a bunch of different algorithms like, where do we insert the ads in a video? Well, it's got 4 different machine learning pipelines running, and they're going, okay, well, we've got to have a dialogue detector. And the dialogue detector has to say, okay, why do you need a dialogue detector? Well, because you don't want to insert an ad right in the middle of like, what I'm saying, right? You want to like finish what I'm saying. And then put the ad in there, right? So you want to do that. And then selecting the correct thumbnail, right, is something that like, which presenting to the user after they've uploaded a video, which thumbnail to pick. The machine learning algorithm selects the right thumbnail with like a huge uptick in clickability, right? Based on this being done sort of like randomly before, or just kind of picking like a couple of keyframes from the beginning or the end, those usually aren't the best ones. And all of a sudden now you've got maybe the only thing that anybody ever sees in that video is that one thumbnail, right? So the machine learning algorithm that's optimized for that, that's just a problem you're not going to solve with kind of the traditional software out there. So people tend to find this. Another company, for instance, we're finding the financial companies, was just talking to Y Data doing a POC. They're specialized in synthetic data. They just got an infusion of capital. Generating effective synthetic data, right? When you cannot necessarily go out and grab all of the data, that's a huge problem, right? It sometimes financial data, you might not have the rights to use it, or you look at the kind of scandal with the health data that's happened, right? But in the past, when they've tried to generate synthetic data, right, for some of those things, it hasn't worked, right? You look at some of the early IBM Watson failures in IBM Watson Health, where they shuttered it. They tried to generate synthetic data, and it wasn't good. So these companies now that are coming along, generating realistic synthetic data to augmented data sets, huge new problem. Again, you're not going to get that from just kind of a quote unquote end-to-end solution, because that might not be the problem that they're set up to solve. They're solving more generic problems that have kind of already been kind of baked, or more baked than someone who's going to go do cutting edge trading algorithms, or needing to do fraud detection and need to generate a bunch. So you're going to need a bespoke tool, and there's going to be no getting around that for a period of time. You're either going to need to build that in house, or you're going to need to get that bespoke tool and integrate it into what you're doing. And that's really just going to be the state of the art for the next couple of years, no matter what anybody's marketing literature says.
That makes a ton of sense, and that's actually probably the best explanation I've heard so far about the fork in the road that buyers have to take. Because that challenge, and that I've looked at a lot of these systems and a lot of these companies and vendors and platforms and products. The challenge is right now, it's very noisy, it's very confusing. All the marketers are saying exactly the same thing. We are an end-to-end system that does everything, solves all problems for all use cases for all customers. They all say the same thing. And there are a good 100 of them out that, beyond what you have in AIIA, there are another, 40, 50, 60 that are out there saying the same thing. And when I dig in and when I meet with them and I have these conversations with them, I'm like, you do 3 of the 40 things that you need. You're not end-to-end. And so, we have these conversations, and it's very tough. But I think that the bigger fork in the road is this, back to the beginning of the conversation. Do I just pick one vendor that kind of says they mostly do everything? Or do I sort of go down the track of really being more selective and curating my own stack? And that takes a level of maturity, right? To know you can't dive into that unless you know what the heck you're doing and you know how to build the car and you know what the enterprise architecture looks like. So you have to have a team who's capable of having that conversation, making smart trade-offs, picking the right partners, kind of future-proofing their own enterprise architecture, and then being prepared to say, well, that component's not working, we're going to swap that out, we're going to put this other one in, and being able to have that level of enterprise architecture around a system that's still being built and still being invented, frankly.
That's right. If you're trying to revolutionize your business model, there's 2 kind of levels of machine learning. One is where you're just kind of integrating some basic design patterns that have already worked, right? If you want to
do what everybody else has been doing.
Yeah, if you want to do some sentiment analysis in order to to route some of your calls to figure out who's the angriest and who needs to triage right away, right?
Yeah.
Like, there's some stuff for that. If you want to be able to detect, transcription from audio, right? There's design patterns for that, right? And maybe you just
more than design patterns, there are off-the-shelf components and or services that just do it.
Exactly. So design patterns and components that do it, and you don't need to reinvent the wheel in these things. But there's a huge chunk of places where you are inventing the wheel, and those are the places where people are really trying to develop a brand new revolutionary business model. I just saw one that was on LinkedIn the other day. I thought it was fantastic, where they were generating models for kind of catalogs. And when we look at catalogs, like, we tend to think like there's a photo shoot. Well, yeah, there's a photo shoot of one kind of like, the hero shot, they call it, of like one of the top, models for like 3 or 4 different ads. But then there's all the 3,000 bits of clothes in the catalog that you can only take so many pictures of those things. You can only take them with so many types of models. So what you do is you hire a range of models, maybe of different shapes and sizes, different colors, different ethnicities, right? But you really aren't going to be able to photograph all of your clothes in that. And then you don't really have any way to know, as the person who's doing the shopping, is this going to fit right on me? Well, now all of a sudden, with this is a revolutionary model to say, we can, pardon the pun, we can generate models in any shape and size, and you'll be able to show all of your clothes on that, and they'll look photorealistic. This is
Yeah.
a game changer. This is a revolutionary business model. You don't build something like first of all, it takes an insight to come up with that business model, that revolutionary business model, and then you're not going to be able to go just grab off the shelf components and buy the O'Reilly book that says how do I generate synthetic models for catalogs, right?
Right.
You just invented something. So you're really going to need to go find and build a number of different pieces. And that's really where the cutting edge is. And I think AIIA companies really represent a lot of these cutting edge stacks, right? If you look, there's no reason that Vertex and SageMaker and Databricks and things like that are not going to solve churn prediction and log analysis and anomaly detection on a few different things. Like these are, there's no reason to reinvent the wheel. But if you're looking at a revolutionary business model and you're looking at a vendor who's on the cutting edge trying to do something that's never been done in history, then you're going to need one of these bespoke vendors or 2 or 3 of them, and you're going to have to figure out a way to integrate them. You're going to need a solutions integrator like yourself, and you're going to need to be able to write some of your own code, and you're going to need to realize that that's going to be the state of the art for a period of time because you are doing the state of the art.
Got it. Excellent. Dan, this went longer than I intended, but I'm glad that we got to dig through all those different things. Where can people, I've got a couple of links that I was thinking of putting up on the screen. I was thinking of your Medium address, your medium.com/. Is that kind of the best place to find your reading, or is it Hacker Noon? And we can always throw stuff into the show notes.
Yeah, I mean, I've written a lot of stuff for Hacker. Yeah, I've written a lot of stuff for Hacker Noon. I would say, Twitter is Dan_Jeffries, the number 1. Don't just do Dan Jeffries.
_Jeffries.
Number 1. See if you pull that one up. I think there. You get it. Otherwise, I think the other Dan Jeffries studies the asexual reproduction of tree frogs. So,
I wouldn't put it past you. I'm sure you've probably written a few reports on that, actually.
I've done a little bit of research, but that fellow's done a lot more. So I've been dabbling in the asexual reproduction of tree frogs.
Let me see if this banner works.
AI-infrastructure.org is correct. The Twitter handle's there, and then the Medium one that you want to get in is just Medium. It's just and then /@Dan.Jeffries. And really, if you Google Dan Jeffries in Medium, you'll also get that. Luckily, Google has been indexing me for years. So
I'm always tempted to just use a "Let me Google that for you" link and just put "Let me Google that for you" and then Dan Jeffries. There you go. Here are all the links. But I'll put all those in the show notes. Awesome. Thank you. I cannot express my appreciation enough. It's been really great to chat with you about this stuff. This is more of a follow-on the conversation we had, but I'm glad we were able to have this one more in public. I want to be able to share this more widely because I think that the work you guys are doing in AIIA is super exciting, really crazy, very chaotic, very Darwinian. I've never seen anything like it before. I think a lot of other people will say they've never seen anything like it. So it's super cool what's going on over there. I think more people need to know about it. So thanks for making time today.
I really appreciate you having me on. It was a fantastic conversation. We got to dig into a whole bunch of wonderful stuff. So
absolutely. Like I said before the podcast, we could probably do a whole series of these, but this will have to do for now. This will be the start.
Awesome.
Thanks for being on, Dan. Appreciate it. And hopefully catch you on a future episode.